Hi, my name is Carlos Mauricio Velasco, and my partner name is Isaiah Giraldo. Today we are going to talk about intelligence agent in business application from hallucination. Introduction. Open with the question. As a chatbot every given you may up answer. The contrast a chatbot leans on predetermined response so it never runs out of options. An autonomous agent perceives this environment, reason about the next steps, and makes independent decisions based on prior knowledge and machine learning. Persistent, flexible, adaptable. Close by proving that today you will of this. Foundation. The problem. Well, through each goes in your own words. Overfitting means the model memorize a specific case but never learn to generalize. Missing grounding means it has no access to verify up-to-date data to check itself against. Learn of the idea that solving grounding in the theory that this the world talk together. Agent architecture. Is this not a left to right pipeline? It's a governance hierarchy. Right oversee three components at once. The client, the infrastructure the user touch, the chat app storage, infrastructure, machine handling, state, persisting, and the orchestrator. Intent recognition, workflow routing. The language model sits alongside the orchestrator as the reasoning engine. Tool calling is the bridge that lets the orchestrator and the LLM actually reach the bottom layer to read a catalog of resources, APIs, semantic indexes, MCP servers, proprietary protocols, and parsing and chunking. Point out that two of tools you will cover in detail later, MCP servers and parsing and chunking in semantic indexes. Saying chunking documents is literally the step before they go into a vector database for RAG. Embeddings. Well, through the four-step pipeline. Emphasize that no single dimension of the vector means country or city. The model has no labeled dimension at all. Semantic meaning only emerges once all dimensions are read together. That's what the last model recognized, that Madrid and Spain are related without every being told so explicit. Vector database. Contrasts with a traditional database with filtered by exact quality. A vector database instead find but what's similar, ranked result by the distant vector space, and is thus is factored even across millions of records. This is the infrastructure piece that makes the next concept, RAG, practical rather than theoretical. RAG, retrievable augmented generation. This is where you close the first loop of the task. You open it with a hallucination for missing grounding. RAG is the direct answer. The models convert the query into a vector, retrieve the most relevant documents, and use them as context before generating a response. Frame agentic RAG as the natural next step toward the agent architecture you are about to cover. Line chain. A line chain is the toolkit around the model, not a replacement for it. Well, through each of the three components with a concrete microexample. Without memory, the agents forget your name mid-conversation. This what lets a team build a real application without rewriting the plumbing every time. Line graph. The key difference from line chain. Line chain chains step mostly in a line. Line graph allows cycles. The agent can revisit a decision, reflect on a past action, and only then move forward. The reflection loops is what makes true multi-agent workflow possible. MCP, Model Context Protocol. Before MCP, connect any models to M tools mean building N per M custom integration. MCP standardizes that language input duration. The same way, USB-C lets any device plug into a port without a proprietary cable, while through the four-step flow without concrete example, that can discover available tools on an MCP server, send a structured request, the server executes the real action and return result, and the agent generates its final response for real data. MCP versus RAG. Close the second loop of the thought here. RAG grounds the answer in real data. MCP grounds the action in real system. Together are the full technical answer to the hallucination problem you open with it.
Our demo context. Everything we just covered in theory we're not going to show you right. As a real AI expense auditor, the user describes an expense in plain language and the agent approves or rejects it. It combines ARG for the policy check, a simulated MCP, call for the ARP budget, check, and LangGraph as the decision flow. Three files map directly to what we just explained: entorno.piles, herramientas.py, and main.py. The first one builds the fake enterprise systems as a SQLite and database standing in for an ARP plus a policy document. The second one builds the two tools, the RG engine and the MCP style isolated database query. And the last one is the LangGraph brain deciding the order to call the name. If you could see, in the first case, we have a 90,000 pesos launch for sales. Extraction the test amount on department. RG retrieves the policy, it's under the 100 limit, so the grab calls the ERP node, budget checks out, and it's approved. In the second case, 150,000 pesos, same, but in a different department. RG flags this exceeds the policy limit and notice the grab skips the ERP call entirely. No was the database query for something already rejected. That's the conditional edge for working for us. And the third case is 70,000 pesos with alcohol included. The amount alone will pass, but the policy explicitly bans alcohol reimbursement. This only works for currently once we visit a real bug. Uh, we hit while building this, which we'll explain next. Okay, analyzing the example, basically that's our stack, LangGraph, local energy with chroma and Hugging face embedding, and a simulated MCP, call against a SQLite, and we have a key decision. Embeddings run locally, no API cost, no latency. The Cloud LLM is only used for reasoning, not retrieval. Here's the honest part. The first version of our policy check prompt only passed the month to the model, not the original description. And case 3 got approved incorrectly because the model never saw the word alcohol, only a number under the limit fixed and under the limit. Fixing it meant passing the full user description alongside the month. It's a real limitation of prompt design, not a research set one. And it's exactly the kind of gap that only shows when you test adversarial cases instead of just a happy path. Other honest limitations that our MCP here is simulated And in a Python function, yeah, not a real MCP server client exists. And our policy document is small, so retrievable quality isn't heavily stress tested, and there is no persistent memory between cases.
This isn't limited to tech. Gen AI native software, real estate, healthcare, non-profits, media. Agents are already showing up across every sector. Now, now let's go deep and three specific cases we researched. The first case has LinkedIn. Um, LinkedIn is hiring an assistant in their first production AI agent. It runs as an ambient agent. It works in the background sourcing candidates overnight and notifies the recruiter when it's done. Instead of waiting in a chat window for a reply, it's built on a Python service framework using gRCPC, LangChain, and LangGraph. Notably, LinkedIn migrated this stack from Java to Python, especially to access the Gen AI ecosystem. Results 60% faster time to interview for small business. The second case, Huber's developer platform team supports about 5,000 engineers across hundreds of millions of lines of code. They build two agentic tools, Validator, which flags code issues in real time, and Autocover, which generates tests automatically. Both run on Lang Effect, an internal wrapper over LangChain and LangGraph, built for reuse across teams. Results over 21,000 developers hours saved. And the third case has BlackRock's Aladdin Copilot runs across their Aladdin platform, over $11 trillion in assets, 100 plus front-end applications. It's built with LangGraph and LangChain, focused on interoperability and evaluation at scale. A filtering step narrows available tools to just 20-30 per query. Every component from prompts to API calls is evaluated daily, and the system is explicitly tested to never give investment advice. It's currently supervised orchestration and not fully autonomous by design, given how regulated the industry is. This declares bright
Choosing an orchestrator means choosing your tolerance for error. Deterministic orchestration is rigid, high precision, but for audits and regulated process. Dynamic elements driven orchestration tolerates variance well good for summation or translation. Hybrids combine but for complex mixed scenarios.
Every architecture has the balance cost, latency, and accuracy. You can maximize all three at once. Connecting an agent to something like an ERP requires an API gateway, unreal security layers, and any action time grades or transacts needs human in the loop. Full automation without oversight on critical action is an unacceptable risk, which is exactly what we saw with BlackRock.
Okay. What did we learn? That building even a small agent means stitching together several concert at owns grounding through RAG, soft tool access through MCP style installation, and orchestration through LangGraph, and that's testing only the happy path hides real gaps. We only found our own prompt, but by deliberate testing and the adversarial case.
Advantages. Modularity. Uh, Basically, we swapped LLM providers mid-project without touching our RAG or database logic. Transparency. Every step brings what it's doing, so failures are traceable, not a black box. And safety. The LLM never touches raw SQL directly. A deterministic function handles that.
Limitations. Cost and latencies are real constraints, not theoretical. We hit free tier rate limits ourselves while while developing this. or MCP is simulated, not a food protocol implementation. And a small police document means we never release stress tested retriable quality.
When will you use this? For repetitive rule-based business decisions, expense approval, compliance checks, ticket triage, where there's a clear policy to check against. Not for open-ended creative work. We're grounding against a fixed document doesn't make sense.
Recommendation: start local and free. SQL Lite, Chroma, and Freetail element to validate to enter flow before paying for any infrastructure. And test your edge case early. The what we found was is the obvious path. It was the case we almost didn't bother testing.
Thank you.